All right. So if I'm being asked the question, is the linear transformation onto, does this mean I'm talking about existence or is this talking uniqueness? So let's remember what the definition of onto is, right? So this is the transformation, domain to codomain. And remember, both onto and one-to-one start here in the codomain. So onto is asking, if I take something in here, is there a vector that goes to it? Is there a vector that goes to it? That's talking existence. And if I'm asking the question, is the transformation one-to-one? Again, we start from in the codomain. So we look here, and we say, is there at most one vector in the domain that goes to this element in the range? Is there at most one? And so that's talking uniqueness. All right, another definition. So here's the matrix A. This is the matrix, we say A transpose. A transpose takes all of the rows and makes them columns. This row turns into this column, row to column, right? All right, so if I have, here's some other just multiplication things. If I have A to the K power, that means A is multiplied times itself K times. So A cubed is A times A times A, right? Okay, that's not much to do with transpose, but we just needed to make sure we know that. So A transpose transpose gives you A back again. This is a biggie. This is something I need to make sure you know. A plus B, taking the sum of two matrices and transposing them, is the same as saying A transpose plus B transpose. Kind of think it almost is like bad math, right? But it's not. Taking a constant times a matrix and transposing it, the constant can come outside. And this is another biggie. If I have AB, the matrix AB transposed, it's the same as saying take the B matrix, transpose it, and multiply it times the A matrix transposed. All right, so let's go do some of these. So here is asking us to go find what AX is equal to, and then transpose it. So let's go find AX. So AX, just write it down here, -2, 4 times 5, 3. So that matrix multiplication gives me -4, 2. All right, so AX transpose is the matrix -4, 2. So this column turns into the row. All right, let's look and see what this one's saying. So this is saying take X transpose, so here's X, so X transpose would be like this, and multiply it times A transpose. So that means this row becomes the column, and this row becomes the column. And then doing matrix multiplication, we get 5 minus 9 is -4. 10, -10 plus a 12, that gives me a 2. Oh, will you look at that? So AX transposed is X transposed A transposed. So these turned out to be the same. Just got to illustrate it. All right, let's try this one. So X transpose times X. So X transpose times X. So doing matrix multiplication, I get 34. So this is a 1 by 2 matrix multiplied by a 2 by 1, so I get a 1 by 1. So it's just the matrix that has the number 34 in it. All right, let's look at what A transpose X transpose would be. So A transpose, 1, -3, -2, 4. X transpose would be 5, 5, 3. No comma there. 5, 3. All right, this is a 2 by 2 matrix. This is a 1 by 2 matrix. This cannot be done, right? Remember, these numbers here have to be the same in order for us to be able to do the matrix multiplication.